military robots and DARPA technologies, a real robot army, and the future of warfare under advanced artificial intelligence. This, as well as incredible new products from military exhibitions in one video.
The Defense Advanced Research Projects Agency, DARPA for short, was created in 1958, almost immediately after the launch of Sputnik 1 by the USSR. The realization that the Soviets were about to launch not only satellites, but also rockets into space, greatly spurred on the United States government. The result was the creation of a unique agency with a huge budget to spend as it saw fit. Watch a selection of DARPA's most unexpected, bizarre, and advanced technologies and artificial intelligence projects in one video. Hey, my name's Connor, and you're on the Pro Robots channel. Subscribe, hit like, and share with your friends. And Elon, if you're watching this, you still owe me $20 for pizza, man. DARPA's mission is to create innovative defense technologies. The agency's projects have ranged from space-based missile shields to cyborg insects. In doing so, the internet, the first computer mouse, GPS, robot vacuum cleaners, and even Siri have been created. DARPA is unique in that by investing in a project, it doesn't seek to grab an equity stake, but only to stimulate the development of technology and see where it leads. The agency's first significant success was ARPANET, which laid the foundation for the modern internet. In 1969, with the help of this computer network, the first message between computers of the University of California and Stanford University was transmitted. But then, out of the 5 letters of the message, they were able to transmit only 2. But on January 1st, 1983, the network became the first in the world to switch to routing data packets. As a routed protocol was initially used, IP protocol was developed by order of DARPA, which today is the main means for data transmission on the internet. In 1964, Charles Rosen, head of the Artificial Intelligence Center at the Stanford Research Institute, proposed the creation of an intelligent automaton for the Office of Advanced Research. The grant was approved, and it was assumed that the developed robot could work as a sort of scout or postman. This is how shaky the robot came to be. According to the description, it could perceive its surroundings, deduce implicit facts from explicit ones, create plans, recover from errors in executing plans, and understand orders written in plain English text. The robot was equipped with video cameras, collision sensors, and a rangefinder. Communication with the control computer was via radio. Shaky software architecture, computer vision, and navigation and planning techniques proved fundamental to robotics and web server development, video game development, and Mars rovers. Autonomous robots, like unmanned vehicles, were one of DARPA's first and primary goals. To stimulate their development, the agency launched the Strategic Computing Initiative in the 1980s and allocated $1 billion to it. The goal is to develop artificial intelligence technologies in a variety of fields. Among the results are the first autonomous cars and Boston Dynamics' first 4-legged walking dog. Modern drones date back to a series of robocar races that DARPA sponsored in the 2000s to encourage the technology's development. And in 2004, of all the contenders for a prize of $1 million, only one managed to pass a modest 12 kilometers of the planned 240. And then in 2005, the entire distance was covered by 5 cars at once. In 2007, DARPA held another race, now with the prize of $2 million. Robo-autos had to drive around the city following the rules and interacting with one another at intersections. It was DARPA that sponsored the development of Boston Dynamics' first 4-legged robot, Big Dog, introduced in 2005. The robot measured 91 by 76 centimeters and weighed 110 kilograms, and was capable of moving at 6.5 kilometers per hour and carrying a load of 150 kilograms, even as well as climbing a mountain, with an incline of up to 35 degrees. The project cost DARPA $42 million, but was shut down as the robot proved to be incredibly noisy. Nevertheless, Big Dog became the basis for the creation of both the Spot and Atlas robots. There were and there are among the agency's projects very unusual and even peculiar ideas. For example, the Energy Autonomous Tactical Robot, or EATR program, was aimed at creating robots that could eat plants to replenish their own energy reserves right where they would work. Or take the Engineering Living Materials, ELM program, which was aimed to create self-healing building materials. With the development of 3D printing of organs and tissues, DARPA hopes to use similar technologies to create hybrid materials that can form and support the growth of artificially created cells. Such materials could be grown locally using available resources. The Hybrid Insect Microelectro-Mechanical Systems Spybug project in 2006 also looked crazy. In 2009, engineers had even unveiled a prototype transmitter for cyborg insects, but judging by the fact that in 2018 the agency announced the start of the development of miniaturized robots controlling insects in the right volume never came to fruition. The new SHRIMP, or Short Range Independent Microbiotic Platforms program, and the robots being developed under it will belong to the smallest type of such mechanisms, just the size of insects. At the same time, the robots will be fast, maneuverable, able to jump, fly, lift objects, and analyze the terrain. And these won't be DARPA's only bio-inspired robots. The agency recently announced that next year it will unveil a fully finished robotic worm that will be able to tunnel at 10 centimeters per second. It has already allocated $2.5 million for the project Underminer. Tunnels will be needed to quickly create tactical pathways when fighting in cities and megacities. One of DARPA's most important projects is the Systems-Based Neurotechnology for Emerging Therapies, a program designed to create an implantable, diagnostic, and therapeutic closed-loop system for the treatment of neuropsychiatric diseases. Essentially, the program wants to create a brain implant to help soldiers combat PTSD and other problems. Interestingly, when work on neural interfaces began, DARPA said that it would create a chip that the military would use to control combat robots and drones with the power of thought. Either way, work on the brain chip continues. Another of the key areas of DARPA's project is the creation of robot pilots and artificial intelligence capable of controlling airplanes and helicopters, including combat aircraft. Thus, at the end of this year, the final test of Alias technology on Sikorsky UH-60M Black Hawk helicopters should take place. The test program includes remote and autonomous missions. The Alias system consists of a robotic pilot, voice interface, and software. Only LiDAR and cameras are required to install Alias on any Black Hawk in the US Army fleet. The trainable artificial intelligence system that will be able to take control of combat aircraft in the future and conduct maneuverable close air combat being developed by DARPA is called Air Combat Evolution. It was for its development that the recent Alpha Dogfights trials test of neural networks algorithms in virtual air combat were conducted. Recall that during trials, artificial intelligence managed to defeat professional pilots of the US Air Force with a resounding score of 5-0. The new neural network system will have to control the fighter and fight faster and more efficiently than a human. It will be tested on a real airplane in 2024. The preparation of the fighter for this event has already begun. Unmanned technology interests DARPA not only in the air, but also in the water. Just the other day, the agency announced that it is ready to sign contracts for long-range unmanned ships with 3 private companies as part of the Sea Train program. The project involves long-range deployment of a distributed fleet of unmanned tactical surface ships. The goal is to break the range limit for maritime drones by reducing wave drag. DARPA sees one solution to this problem in sea trains, which will be formed from ships right in the sea. Having overcome the necessary distance, marine drones will disconnect to fulfill their task, and then on the way back, they'll make it train again. Also, it's at the expense of drone technology development that the US intends to bring the number of its fleet to 355 ships. This was recently stated by US Secretary of Defense Mark Esper, and he also reported on the demonstration of a prototype of an underwater drone, Echo Voyager, from Boeing, and surface vehicle, Sea Hunter, developed by DARPA. Apparently, they will be used to replenish the Navy's ranks. Another global goal of DARPA is the creation of swarm intelligence, that is, the use of groups of robots to perform complex tasks. As a part of this project, researchers from the University of Buffalo recently received more than $300,000 to study the brain impulses and eye movements of gamers. The goal is to improve the organization and strategy of autonomous aerial and ground robots through a new learning method. The robots will be trained by an algorithm that must process the information collected by scientists and understand how gamers act in some unexpected situation, what they pay attention to, and what these actions lead to. Robot swarms are being researched by DARPA in two other areas. The first is the Offset project, the development of software that will allow various ground robots and unmanned aerial vehicles to work together. Robots grouped together must be able to cooperatively accomplish one or more tasks, using one or more than 100 tactical options. The second area is the Squad X project. It involves the introduction of drones, robots, and sensors on the battlefield to maximize soldiers' situational awareness and other tasks. DARPA has already tested the program through a week-long exercise in which U.S. Marines used drones and robots to coordinate their movements and detect potential threats in the field. Information from the sensors was processed by an artificial intelligence system and only then relayed to the military. This is exactly how the combat scenarios of the future will look like. We cannot fail to mention that thanks to DARPA, the whole world was able to enjoy the spectacle of humanoid robots racing at the DARPA Robotics Challenge. The footage of epic fails of robots of various designs quickly became a hit on YouTube. And while it's indeed very funny, we can't forget that thanks to such events, robotics is evolving and today we can watch agile robots like Atlas. Subscribe to the channel, like, share this video with your friends, and don't miss new episodes.
U.S. Army generals say they expect mass adoption of robot soldiers between 2030 and 2040. And despite the fact that the public, majority at least, is strongly opposed, the military's opinion is this: if we don't do it, other countries will. So the future of using armed robots of all shapes and sizes in U.S. military is not an after-school special. Already now, the amazing technologies of the future are being tested, causing both admiration and concern. First up, Lockheed Martin. They unveiled the revolutionary Onyx exoskeleton. Designed for the lower body and equipped with miniaturized servos, sensors, and artificial intelligence technology, not only increases strength and endurance, but also greatly reduces the risk of injury. The Onyx control system learns and then adapts to the fighter's movements by detecting the type of terrain and amount of workload. The device is deactivated when traveling lightly, but activated when climbing or descending a mountain, for example. Weighing only 14 pounds or 6.5 kilos, and with 16 hours of battery life, the Onyx becomes a real lifesaver for soldiers who often carry 100 pounds, 45 kilos, or more on their back. Word on the street, Onyx has already been tried out in the field and has been given the green light. It won't be cheap, probably in excess of tens of thousands of dollars, but when it comes down to military spending, who's counting, right? It's education and health we should be nickel and diming about. That's where we need prudence. And let me riddle you this. What's the most dangerous job in the military conflict? Obviously, no job is easy, but being a stormtrooper, when you know for sure that the plot right over there is full of IEDs, definitely one of the most terrible things to do. And it's the kind of job that robots are best suited for. That's why the U.S. Army is paying for Cybernet, not to confuse with Cyberdyne, to develop the perfect assault robot. Right now, a robotic system is being mounted on two types of assault breacher armored vehicle. One goes in front, in charge of demining, and the other goes behind it to fill in anti-tank trenches, opening the way for the main units to roll out. Both robots are controlled from a single command post. But in the near future, the vehicles will be replaced by a full 10-ton TRX breacher tracked robot from General Dynamics Land Systems. And when this robotic destroyer marches on in a war zone, no one's going to be able to stop it. Recent real-world conflicts show that the battlefield today is two sides separated by the signal of an FPV drone, peppered by artillery fire here and there. Swarms of drones is a nightmare, and no one has the answer on how to combat them today. However, Northrop Grumman hopes to break down this wall and is developing a high-speed artillery system with smart munitions. They are capable of targeting themselves and massively destroying a variety of drones, and for a ridiculous price compared to the cost of a single shot of a missile defense system, which comes down to millions of dollars. The new system, called CBAD, consists of long-range missiles to eliminate supersonic and hypersonic threats, long-range large-caliber guns, medium-caliber medium-range guns, and short-range small-caliber guns.
These are layered defenses with a different type of projectile for each threat, and they're fired at machine gun speed. The kicker? The ammo is auto-targeted. Each round finds its target, heads towards it, and explodes on impact, hitting it with shrapnel. It's effective and cheap. According to experts, nearly 100% cheaper than a standard air defense round. And there can be 200 to 400 charges in a battery instead of 2 to 6 missiles in an air defense system. But you know what's really surprising? The fact that it's not even the killer smart US weapon system. Ghost Robotics Vision 60. That's where the magic happens. Real dogs of war here. These robots are designed with one purpose and one purpose only: to engage in armed conflict. They're already scouring tunnels, patrolling US military bases, and serve as a platform for weapons experiments. For example, tests are now being conducted with the use of robot dogs in counter defense. For this purpose, the Vision 60 has been equipped with a special carbine for hunting drones, a guidance system with infrared and thermal imaging modes, and a laser designator. The entire robotic system is controlled via tablets just like a drone would. Now, the $165,000 Vision 60 is equipped with multiple cameras and microphones capable of getting up on its own after falls and collecting sensor information for targets, including target designation for other weapon systems. Robotic dogs are now becoming an increasingly affordable and widespread technology, but in our opinion, they're unlikely to be particularly widespread. It's reasonable to use them only where a wheeled or a caterpillar robot cannot pass. There are dozens of such platforms today, and it's not easy for robot dogs to compete with them. Ripsaw M5 and Striker X are certainly not competitors to robot dogs. They are much bigger and stronger platforms. Ripsaw M5 is a powerful advanced autonomous robot for convoy, reconnaissance, deterrence, and bomb disposal. 360 cameras, speed, maneuverability, stealth, and a little friend in the form of a drone on board of this vehicle make it attractive for a variety of missions, including US Army's Robotic Combat Vehicle Medium program. The Striker X robot, on the other hand, can fire laser weapons, launch drone attacks, and engage in electronic warfare. It has a hybrid electric motor for quieter operations, so the vehicle can conduct reconnaissance missions. It also has an autonomous 30mm cannon for long-range target practice. The robot's capabilities are constantly expanding, but it's still not as cool and necessary for the Army as this next bad boy. Upscale tech is needed not only on the ground but also in the sky. Lockheed Martin's F-35 Lightning II, for example, is the most expensive military fighter jet in history. $109 million with an annual upkeep of $6.6 million. The real breakthrough, though, is not in the jet itself, although that is a work of art on its own. But the real gem is in the Gen 3 HMDS helmet developed by Collins Aerospace. This $400,000 helmet provides pilots with a unique 360 view of the entire F-35. This is possible because, in addition to stealth technology and vertical takeoff, the F-35 is equipped with 6 body-mounted cameras that transmit images to the helmet visor. This is especially important when the fighter jet is hovering in place, for example. In addition, the Gen 3 HMDS displays flight information, gives you night vision around and through the aircraft, and allows you to operate weapons and track targets just by looking at them. Meanwhile, each helmet is customized to the pilot using 3D scans of their head. And if you suddenly change your hairstyle or suddenly get addicted to Cinnabons, the helmet, which costs as much as an apartment in Miami Beach, will have to be redesigned. Is that in line with the Agile framework, or is that Scrum? I could never tell. Textron Systems has unveiled Seacat, a revolutionary warship that runs on water at incredible speeds. On top of this wizardry, it can carry a boatload of cargo over huge distances. At the same time, it doesn't need a dock, a crane, or even water for that matter to land and unload. The Seacat operates on the same principle as heavy lift screen gliders, which fly low, gaining additional lift and efficiency by keeping a cushion of air between the wings and the surface of the water. This landing craft can reach speeds of almost 60 miles or 100 kilometers per hour, practically hovering above water. Seacat can be fully or partially autonomous, carry people, and travel distances of up to 1,000 miles or several thousand kilometers. And its payload capacity is 600 tons, which for comparison is 10 of the most pimped out M1 Abrams tanks with full armament. Seacat is lean, maneuverable, and can land anywhere, so the Marines don't even have to get their feet wet. In addition, this marvel of engineering is resistant to level 4 storms. It's an all-in-one type of thing. And I know I've already said this, but this next one is out of this world. This silent modular drone can independently find an object, figure out what it is, and track it by intelligently navigating the terrain and airspace. Moreover, while most military drones require several people and a decent amount of time to deploy, the Ghost X can be sent on a mission in just a couple of minutes. The drone from Anduril has computer vision onboard computing systems, a range of 15 miles or 25 kilometers, and a flight time of up to 75 minutes. It weighs only 55 pounds or 25 kilos and can carry 20 pounds or 9 kilos. This is enough both to equip it with light weapons and, for example, to deliver first aid kits. Ghost X is first and foremost a smart and cautious reconnaissance drone. The drone can fly and perform missions in bad weather, becoming the eyes of the infantry, ensuring their safety and allowing them to make important, timely decisions. What's more, it can even dive up to 3 feet or a meter underwater. We can end here, really, but my producers wanted to rock your socks, so here goes. Context AI. That is a game changer. It's not a robot, it's artificial intelligence for C4ISR, the nervous system of modern military. The acronym C4ISR stands for Command, Control, Communications, Computerization, Intelligence, Surveillance, and Reconnaissance, or simply eyes and ears. And artificial intelligence in this system is invaluable as it processes huge amounts of data and allows the military to make informed decisions at lightning speeds. Moreover, Context AI is capable of predicting certain events and offering options to influence them. Another goal of this technology is to ensure cybersecurity. Military people claim that the technology is immune to hallucinations inherent in all popular generative AI systems, such as ChatGPT. The model from Resecurity Inc. is trained on 40 billion records from the dark web and different intelligence sources. This allows it to pinpoint threats, identify misinformation campaigns, and suggest how to deal with them. Context AI is already in use in 8 nations around the world, but this system unfortunately still can't tell us where $2.3 trillion went the night before the Twin Towers and Building 7 came down. Another gem we got for you, the US Army has tested Roman, a tracked robot with 2 arms designed to clear debris, deliver dangerous goods, and perform many other tasks. Soldiers can simply tell the robot to clear the road or open a bag, and the robot will decide how best to carry out these orders. Moreover, the robot is able to analyze unknown objects and choose the best way to deal with them. Roman is smart, strong, and can pass through any terrain. It's slow, but they're working on it. Who, you ask? Why, DARPA, of course. Actually, NASA crafted an autonomous machine for moving over difficult terrain for DARPA recently. The Robo-Simian is inspired, as you might guess, by monkeys and is still being tested for use during natural disasters and other emergencies. To us, it seems that if this robot's going to be used in real life, it's more likely to be amongst civilians. That's where many of DARPA's contraptions end up anyway, like the internet, for example. If you want to hear more, click the cards. So the robot army is almost here. Land, sky, water, you name it. All that remains is the ability to learn how to coordinate the actions of all the robots among themselves with just a handful of, hopefully, human operators. At the same time, the decision to use robot weaponry against people should be made only by humans or not? What do you guys think? Let us know in the comments below. Otherwise, subscribe to our channel, like our videos, and check out our Instagram for more from the world of high tech.
War. War never changes. Or does it? Yes, the essence of war remains the same. It's the highest form of competitive struggle. According to military theorist Karl von Clausewitz, it's an act of violence to subjugate the will of an opponent. It is the most dangerous, but also the most productive activity of human societies. War, whether we like it or not, sets in motion and changes all spheres of life: culture, social relations, and of course, technology. Technology has already twice in human history completely changed not the essence, but the very face of war. The first time was gunpowder. It changed not only the tactics on the battlefield, firearms created new social relations and new power. It was not determined by origin anymore, but rather by who had the gun. The second time was nuclear weapons. It jeopardized the very existence of humanity. It also made a new full-scale war impossible, and instead came a world of cold wars, proxy wars, wars of terror, and hybrid wars, but never a direct war between high-tech powers. We live in a decade that could spawn several technologies at once that will change everything. Artificial intelligence, breakthroughs in robotics, physics, and bioengineering. Warfare will involve robots, drones, cyborg viruses, quantum computers, and new forms of intelligence. But the main thing in the next military revolution is to change the very concepts of war and peace. What technologies will be crucial? Some of them, for now, remain science fiction, but some are already being applied on the battlefield. What are the new possibilities and what dangers do they present? Is there any way to contain the arms race? And how will it change the face of warfare? We're going to talk about how the key technologies around which the battle for supremacy between states and other players are already underway today. And how it will end is up to you to decide, because man remains the main actor and the main target of this war. The war of the future, or the next war, was already talked about in the early 2010s, when it became clear that the end of history in the 1990s did not happen, and world powers will continue to compete for first place on the planet. The number of state conflicts has been growing since 2012, global military expenditures since 2014. By the end of the 2010s, it became obvious for all states that the conflict at the level of diplomacy and economy has its limits. And since the contradictions of the world do not become less, the probability of direct military clashes between individual large states and allied blocs increases. Already in November 2015, the US Senate held a meeting for its Armed Services Committee, with the stated theme, "The Future of War." Senator John McCain opened the meeting as follows. Today we are focused on the future, on what will be decisive on the battlefields of tomorrow, what technologies our future warfighters will need, and how we can reform our defense institutions so that they adapt at the speed of its innovation, not bureaucracy. In attendance were the heads of committees responsible for cybersecurity, strategic investments, and representatives from foundations and academic groups within the US Armed Forces. Their task was to determine what the war of the future would look like and how to prepare for it. Even then, the military realized that the likely enemy in this conflict would not be insurgents with Kalashnikovs or the army of a shaky state frozen in the 20th century, but an enemy directly competing with the United States in high-tech fields. Promising directions were clear even then. Big data and neural networks to help process it, unmanned aerial vehicles and robots to save soldiers, the possibility of autonomous combat systems that completely eliminate the human factor, militarization of space and warfare in a digital environment where reliable communications will be critical. By 2023, technological competition in each of these areas has peaked, and practical competition is already underway on the battlefields, for now in proxy conflicts. Drawing on reports from organizations and experts assessing the applications, limitations, and prospects of these technologies, let's find out what could change the rules of the game as early as tomorrow. The civilian sphere is abuzz with headlines about godlike artificial general intelligence, which is already close. Elon Musk said that it could appear very soon, as early as 2029, but the military does not take this factor into account, at least in public reports. At the same time, back in 2014, the very developments based on artificial intelligence were called by the Secretary of the US Department of Defense, Chuck Hagel, decisive in the new generation of military operations. Plans for the introduction of military technologies in general are distinguished by their long-term nature. For example, China is using the developments on AI that began in the 80s. The main institutes and programs were deployed in the 2000s, and the plan for gradual modernization of the People's Liberation Army of China is phased until 2035. The role of neural networks and trained models in all high-tech armies is already great today, and according to all forecasts, it will only grow. AI is particularly useful in the task of intelligence and logistics, planning operation, and training personnel. An example of such integration of artificial intelligence systems is Palantir. No, it's not one of Saruman's orb from Lord of the Rings for you hobbits watching. It's an American company that's been developing solutions for interactive virtual analysis of large datasets since 2003. Let's imagine a battlefield. There are a lot of objects on it, and their location is constantly changing. A person simply can't physically keep track of everything that's happening. Here, intelligence systems come in handy. They allow you to collect disparate information coming from the battlefield, remove unnecessary noise, highlight changes, patterns, and anomalies, and give the superior officer at the command post visual clues with recommendations. Artificial intelligence is perfectly capable of handling monotonous tasks, allowing it to process massive amounts of data and eliminate errors due to human error, allowing the operator to focus on decision-making and battle planning. Palantir's solutions for 2023 are widely integrated in the U.S. military and intelligence agencies, and similar systems are used in the civilian sector, and manufacturing to prevent accidents, and business analytics, and finance, and government. But they have enough limitations. The first and most important is hardware. Despite the fact that the U.S. has the most military hardware in the world, the data that can come from it for AI training is not used, because what is needed is either lost or outdated. A lot of it is just somewhere collecting dust. And in the history of the Pentagon, the task of combining the information into one database has never happened. This is for numerous reasons, but mainly for security. This problem is temporary. It is solved by the modernization of equipment and structuring of databases. But the second limitation is more fundamental. The very nature of today's artificial intelligence models is such that they show good results on a controlled environment, but with a limited range of tasks while on the battlefield, conditions and tasks are constantly changing. AI is able to process data well and notice changes in it, but making adequate decisions, weighing all the pros and cons, taking into account all the nuances, and most importantly, taking responsibility for the result is not currently feasible and is not likely to be in the foreseeable future. The third factor is that intelligence systems can't be relied too heavily on in combat operations against a technologically comparable enemy. Since the 90s, the Pentagon has been conducting military reform in the concept of network-centric warfare. This implies intelligent information interaction between soldiers on the battlefield united in a single information network. When satellites, unmanned reconnaissance, and communication channels all allow individual units having more data on hand to act with a degree of autonomy. But if two forces using such systems clash, it opens up the possibility of exploiting their vulnerabilities, blinding and disorienting the enemy, leaving them without the usual support, for example, through electronic warfare or hacker attacks. As long as there is no artificial intelligence on the planet equal to human intelligence, humans will always figure out how to find blind spots in the enemy's systems and outwit them. In a speculative scenario, if someone achieves sufficiently universal artificial intelligence, he will have a huge advantage. But the fact that it will immediately end up in the hands of the state or leave the military sector is rather unlikely. Programs to support military development of artificial intelligence in the US have existed for about 10 years, and for the same number of years, there have been complaints about their inadequate funding, lagging far behind the private sector. US developers of general-purpose robots oppose turning them into weapons, while multinational corporations that lead the data market are bypassing large military contracts altogether. Corporations are focused on the global market, not the interest of a single state. In China, the army uses the model of private contractors, and most of the developments of the field of AI are created by extensive networks of private companies, including those working for the institutions of the Chinese army. And Chinese civilian sector has long since pulled ahead in data collection. So the chance that a general artificial intelligence will immediately gain access to nuclear codes is still pretty small. More likely, it's going to try to sell you something. Already today, AI systems are being used in warfare, changing fundamental approaches to intelligence, battlefield communication, and troop management. Going forward, all technologically advanced armies plan to rely more on the intelligent systems, modernizing the technical base for data processing and leaking troops into the military Internet of Things. With it, the military will have previously unprecedented battlefield situational awareness. So artificial intelligence is a reliable assistant in the near future, but key decisions will still be made by humans. The most important task in this case is to save the people in charge of these systems. The value of a military specialist's life is only growing. Unmanned systems, on the contrary, are becoming cheaper and moving from piece-to-piece mass productions. For example, in 2007, MQ-9 Reaper units conducted reconnaissance and carried out pinpoint strikes in Iraq and Afghanistan. Now, in the civilian sector, drones for photography, pizza delivery, and fishing are being mass-produced, while in the military sector, similar drones can take pictures of the enemy positions, deliver explosive, and rescue the wounded. Drones are effective in the task of cargo delivery, safe for the operator to hit targets, reconnaissance, convoy escort, and territory protection. They can do all of this in the air and on the ground, in the water, underwater, and even in space. For the first time, unmanned systems were developed. Together with satellite constellations, drones have proven to be indispensable visual control tools. They complete the picture of the battlefield in real time, and guided ballistic missiles and explosive drones demonstrate frightening accuracy. In large metropolitan areas, unmanned cars and trucks are being tested, keep drivers safe, and save transportation. The same developments are being created for military equipment, the cost of production of which and training of personnel is much higher. In the future, we can talk about unmanned tanks, transports, ships, airplanes as the norm on the battlefield. Today, the US has already developed about 36 unmanned drones for different combat missions. Russia is testing unmanned tank platforms. China is developing an aircraft carrier with drones on board, and Iran, Turkey, and Israel are all producing their own drones. But unmanned systems also have their limits. In a direct collision, unmanned aerial vehicles are inferior to a trained pilot, so auxiliary systems in large aviation will be developed, but in critical moments, there will still be an experienced ace at the helm, who, of course, if unmanned systems are available, won't be sent on a suicide mission, but rather saved for more complex and responsible tasks. Unmanned systems are also extremely vulnerable to electronic warfare. The people at the helm still haven't learned how to disable the interference, but to lose expensive equipment in the presence of an enemy that has adequate air defense, well, they're great at that. This leads militaries to the production of disposable unmanned systems, which, while expensive, are not as bad as losing real humans. But all this greatly limits the use of drones against a prepared enemy, and the modern battlefield is saved from swarms of drones circling in the sky day and night by the relatively short battery life, one of the biggest problems in recent years, and another area of the real technological race. Year after year, we're promised new breakthroughs in the way we store energy, and invest huge resources in doing so, but we're still mostly using lithium-ion batteries, a technology that hasn't changed much since 1991 when it was first introduced. The first such mass-produced battery was from Sony when it hit the market. In less than 10 years, drones have gone from being rare special operations assets and toys for civilians to a distinct type of weaponry, creating and occupying an important niche in the battlefield and opening up new possibilities for the use of military hardware. But a fully unmanned robot versus robot war is still a long way off. Humans on the ground still decide the outcome of battles and bear all the burdens of war. In 2022, a video called Slaughterbots by the Future of Life Institute, the same organization that recently tried to halt the development of systems more powerful than GPT-4, appeared online. It called for a ban on the use of weapons that use algorithms to make autonomous decisions to eliminate targets. Fully autonomous systems are a logical development of unmanned technologies when the technology doesn't need or require to perform all the tasks. But when it comes to such weapons, complex moral, ethical, and legal questions arise. Who is responsible for robot decisions that could lead to unwanted casualties? How can these systems be secured against possible mistakes? Since 2017, Future of Life Institute, Stop Killer Robots, and other organizations have been actively pushing to ban autonomous weapons at the UN level, asking countries to join a convention similar to nuclear weapons. But most countries have their own developments in this area: the United States, Israel, Russia, and China, and all of them are still delaying the signing of such a convention. For a long time, there's been a debate about what should be considered an autonomous weapon. For example, the Israeli firm IAI was one of the first to develop and supply Herald drones, which operate on a shoot-and-forget principle, like a self-guided projectile. But since the decision to launch the target is made by a human being, this doesn't truly count as an autonomous weapon. The organization, Stop Killer Robots, advocates defining autonomous systems as having no meaningful human control. That is, if a drone can be programmed to destroy a certain type of target and make the decision to attack on its own, it's an autonomous weapon that should fall under the ban. While lawyers are sorting out the term, the development of the use of autonomous weapons is in full swing. UAVs and guided ballistic missiles of varying degrees of autonomy are produced by Israel, Russia, China, the United States, Korea, the United Kingdom. The list goes on. Autonomous weapons can technically be considered smart mines that are triggered when specific parameters are met. The Mine Convention at the UN in the 90s, by the way, also failed. The Ottawa Accords were signed instead without the US, Russia, and China. There are also compromise proposals to allow the use of only defensive autonomous systems, like Turkish patrol biplanes or automatic air defense systems, or to use them only against other machines and robots. But here comes the biggest potential danger of autonomous weapons. What happens if the autonomous weapons of two countries collide and decide to start a war without the knowledge and consent of the people? Such a situation could lead to a major conflict, up to and including nuclear escalation and World War III. For now, the legal status of fully autonomous weapons is not yet clear, and fully autonomous systems are still more of a speculative danger. All the big players, although not entering into conventions, have their own ethical principles for restricting these systems in their decision-making. In the near future, self-guided missiles and drones will be tested, and their use will expand. Such technology is especially valuable in hard-to-reach areas. Deserts, the Arctic, underwater, and the launch of ships with autopilot can help save a lot in the cost of maintaining sailors. They are also good for simple tasks with a set scenario, such as patrolling and guarding objects. And whether uncontrollable swarms of killer robots are waiting for us in the near future, the actions of which can be anonymous and unpredictable, will be determined by the development of artificial intelligence algorithms, as well as the ability to create dialogue and trust in each other as the main producers. The topic of space militarization has not been discussed so actively, probably since Reagan and Star Wars. The main emphasis in the technological equipment of the future wars is placed on communications, and reliable satellite communications is a priority. Recently, its capabilities and limitations have shown. Russia, China, and even Starlink from Elon Musk are increasing their satellite constellations, and other countries are joining launches. Since the early 2010s, the total number of new satellites in orbit is growing from year to year, and not all of them are exclusively civilian. However, space is far away and hard to wage war in, and the defeat of the enemy's orbital constellation of satellites is still a purely theoretical scenario. Any space development is expensive and complicated, and in case of a global war, satellites are the first thing to be destroyed. We're still not sure how to protect them. Therefore, a reasonable solution is to create a backup protected ground-based communication system. Quantum communication can become a substitute, as quantum communication cannot be intercepted. They are instantaneous and reliable. At the same time, breakthroughs in quantum computing may in the near future turn the world to encryption, making almost all modern cryptographic methods obsolete. In the struggle of satellite constellations for a place under the sun, the most promising area looks like low orbits, where you can throw a network of small satellites, multiplying the accuracy of data and what is happening on real time on the ground. So Russia recently tested the first low orbit satellites, and no doubt others will soon join the exploration of these great heights. Cyber warfare will be to the 21st century what Blitzkrieg was to the 20th century. General V.P. Malik, Chief of Staff, Indian Army, year 2000. In addition to land, water, air, and space, modern military theory since 1995 has emphasized another area, information, or cyberspace. In it, operations are also prepared, specialists are trained, and war is waged, only not with kinetic, but with informational weapons. As people become more involved in the virtual world, the importance of this theater of war grows. And if earlier information operations were mainly engaged in intelligence, agents, and hacker groups, then with the new round of development of bots, neural networks, and opportunities for individual influence, it involves almost the entire population of the countries involved in the conflict. The forms of confrontation are extremely diverse. Recruitment of agents, sabotage, provocation, disinformation, and cyber attacks on digital and physical infrastructures. In recent years, there's even been a discussion of another dimension of warfare, cognitive, when it's the goal not to control the information, but to control the very thinking of the enemy. This makes more sense. If more and more of an individual's environment becomes virtual, then his thinking is controlled by the one who curates the environment. The main objective of cyber attacks and cognitive warfare is to suppress the morale of the enemy's army and the morale of its civilian population through available communication channels. The digital and physical worlds are merging more and more closely every year, which means the information infrastructure, data centers, and communications is as important as power plants and pipelines. The virtual world is taking on more and more functions, becoming more and more complex and more vulnerable, which means that the adversary, and not necessarily the state, will hit it. States are aware of this and are preparing to the best of their ability. For example, in 2021, Israel, together with the World Bank and 10 other countries, conducted exercises to repel anonymous cyber attacks, which rumor has it paralyzed the financial and banking systems of several countries, bringing them to the brink of economic collapse. In total, 3 critical technologies can be identified, which in the future may shift the main focus of combat operations into cyberspace. These are generative models and artificial intelligence, which will expand the digital world by an order of magnitude. Possible breakthroughs in human-machine interfaces, developments like Neuralink that could change the very way we interact with the digital world, and finally, quantum computing and quantum computers that will provide the necessary power for such a digital revolution. But what stops humanity from moving the future of war completely beyond the monitor screen is the one vulnerable node that resides in the physical world. The energy infrastructure, if it is destroyed or damaged by a coordinated cyber attack, the most advanced digital systems will turn into useless scrap metal in an instant, and virtual violence will immediately revert to the real thing. The Center for Strategic and International Studies' April 2023 report, 7 Critical Technologies to Win the Next War, recommends that the US government and the Pentagon focus on 7 key technology areas. Here's a list of them: secure and reliable communications, quantum technologies, bioengineering, cosmic technologies, high-performance batteries, and artificial intelligence robots. In total, scientists identify 56 specific technologies, the possession of which will be a serious competitive advantage in the war of the future. In this medical standings of the technological race, the states will follow each other, gradually introducing new technological means into their armies and trying not to lag too far behind their nearest competitors. The player who becomes the first in the few key technologies may gain a serious military advantage. The one who fails to move quickly enough into the next technological era will likely cease to exist. At the same time, warfare will not change beyond recognition in the near future. It will combine the elements we already know: trench fighting of the First World War, mechanized attacks of the Second, and guerrilla actions of the Cold War, and then modern cyber warfare. But there will likely be no bright nuclear outbreak of World War III. Instead, it will slowly smolder, spreading wider and wider by general instability, rebellions, and localized conflicts, in which more and more technical means will be used. Nuclear deterrence will gradually recede into the background, but it is still a guarantee of mutual destruction. And as long as it does, new types of warfare will emerge to circumvent it. The real technological revolution is taking place every day before our eyes, in the civil, military, and spiritual spheres, through the merging of the digital and analog worlds, the blurring of the very line between peace and war, in which literally everything becomes a weapon. From a post on the internet to a digitized DNA sequence, and everyone from a housewife with a smartphone to a soldier in the line of fire is an equal participant. The main element of the tectonic shift that is changing the face of the war right before our eyes, just as gunpowder and the splitting of the atom once did, is data. All the technologies described in this review are just private attempts from different sides to ride this new element, in the struggle for control of which between states, corporations, shadow structures, and individual, the main conflict of the 21st century is outlined.
Since the dawn of man, killing each other has been big. It doesn't matter if you believe wars are started for resources, or you listen to Billy Carson and believe aliens manufactured humans and taught us how to wage war on one another, or even that a global cabal blackmails those in power with pizza to manipulate events into terror and destruction around the world. Facts are, wars exist. According to accepted history, a lot of tech we use today came from the military, like the internet, for example. Obviously, the recent explosion of robotics and AI did not go unnoticed by the armed forces, which is why today we will take you on a journey through the Eurosatory 2024 Military Tech Exhibition and find out just how far killing machines have advanced. In other words, folks, no man's land is ahead, but we got your six. The first Bravo Zulu on our list is Rolls-Royce. They managed to stick the word hybrid onto a diesel engine. This apparently makes tanks and POVs more efficient and also camouflages them. While still a concept, this 10-cylinder engine has 1100 kilowatt of power, which is about 10 times more than your Camry, and is surprisingly small. But most importantly, it's very good at stealth. Rolls-Royce claims the hybrid engine provides better camouflage by allowing the diesel engine to be switched off while it's powered by batteries. This makes the vehicle much quieter and significantly reduces its heat signature in the battlefield. The big question is, will Predator be able to track this concept engine down, however, remains unknown. Rheinmetall and Lockheed Martin are next up, patting each other on the back for GMARS, Global Mobile Artillery Rocket System. The wheels come from the former, while the shells from the latter. NATO is eagerly clapping its hands because now they'll have that with MLRs and HIMARS. The system can track short and long-range targets and sports an integrated crane that makes the vehicle self-supporting and capable of safely packing its own containers. I wish my kids were like that. GMARS weighs more than 40 tons but can reach speeds of up to 60 miles or 100 kilometers per hour and has a range of 430 miles or 700 kilometers. This also means that the vehicle has a shoot and run capability, meaning it can launch missiles and disappear long before the enemy retaliates. In that sense, although GMARS is a unique system, there are several analogs around the world, most notably North Korea's trash balloons. Let's Charlie Mike. Teledyne FLIR, not to be confused with Cyberdyne, showcased the SUG-V 325 robot at the show. Basically, it's an electrically powered tracked platform. Highly mobile off-road and in urban environments, it weighs 20 pounds or 9 kilos and is really easy to carry. The robot is equipped with high-res and long-wave infrared cameras that provide all-round vision and a two-way audio system that makes the SUG-V 325 the eyes and ears of the operator. In an hour, the SUG-V can traverse 7 miles or 11 kilometers and can climb 45-degree angle slopes. We are still unsure if that's the equipment that was used during the presidential debates recently, but we'll keep you updated. And Hyundai brought its drone countermeasure systems to the show. The Sky Spider all-in-one system is designed to counter enemy UAVs with either machine gun fire or a grenade launcher, which can use programmable ammunition. On top, the Sky Spider has a radar, a 12-mile or a 20-kilometer sat-nav jamming system, a control module, and an optronic system. If you're shopping for one of these bad boys, say, for your backyard, you can also add, for example, an acoustic detection system for drones. And you won't even have to monitor anything, because the Sky Spider comes with its very own AI to identify and select targets, just like Huawei's equipment. Quick side note, the Eurosatory 2024 is held in France, so naturally the French army put on a show by parading their latest gen of armored vehicles named after animals not indigenous to the country, namely Griffin, Jaguar, APC Piranha 3C, and Caesar. Now, in case there's a fire, call Shark Robotics. They brought their UGV Colossus, a firefighting robot best known for helping out with Notre Dame. Colossus is equipped with a self-cooling system that allows it to operate in extreme temperatures. The robot can carry 1,100 pounds or 500 kilos and is currently remote controlled. However, engineers are already working on a fully autonomous system controlled by artificial intelligence. The device is powered by replaceable lithium-ion batteries and, unlike its Rotos counterpart, can operate up to 12 hours. Swiss company TechPro Technologies showed their robotic boat with a range of 2,000 nautical miles or 3,700 kilometers. It's known that Vidar FP is characterized by low visibility, it's fully autonomous, and is already undergoing sea trials in the Baltics. The boat's engine compartment is recessed deep into the hull, ensuring minimum heat signature. The cooling system reduces the temperature of the exhaust gases so that they're not detected by thermal imaging cameras from the aircraft. The boat is equipped with a 40x magnification vision system that can see over 4 nautical miles or 7 kilometers away. Also, to get a better look at what's out there over the horizon, Vidar FP can launch its own onboard drone linked to the boat by a tether to lower the electronic signature and communicate with the main computer. Just like this girl I'm seeing, the boat is able to follow instructions, avoid collisions, and even operate for up to 9 hours on its own. And Arcus unveiled the Drailer robotic fighter support platform. The vehicle is equipped with independent suspension, can carry up to 1,500 pounds or 700 kilos of payload, and can climb gradients of up to 60 degrees and side slopes of up to 30 degrees. Drailer is designed for long-range missions. It can travel up to 124 miles or 200 kilometers at a speed of only 12 miles or 20 kilometers per hour though. It has a gun that can be remotely controlled, and the iOS on this bad boy is based on an open architecture, which means easy integration of different modules. Fun fact about Drailer: it will simply ignore a human command that could jeopardize the robot itself, which should be a breeze for it because it has lidars and cameras front and center. The current version of the platform works in different modes: teleoperation, human and vehicle following, and waypoint navigation. Ultimately, however, Arcus wants full autonomy for Drailer, which is expected in the next 5 to 6 years, just in time for Agenda 2030. Meanwhile, a Turkish defense company, hope I'm pronouncing this correctly, Aselsan, presented top-notch air defense systems. Among them are electronic warfare, enemy detection systems, and communications. For example, the Skydome system, which is designed to provide reliable defense against diverse air threats, including drone swarm attacks and barrage munitions. The system includes early warning radars and means of defeating air targets at both short and long ranges. Another system, the Korkut, otherwise known as Fear, has 3 armed platforms that can all operate simultaneously from one vehicle. It's capable of firing up to 1,100 rounds per minute and can hit targets at a distance of 2.5 miles or 4 kilometers, which is almost as accurate as the Turkish soccer team. Airbus decided to flex and brought its Flex Rotor drone to the show. Nothing new here, it's been around for the last decade and a half, but sold under the Aeroville brand, later bought by Airbus. The drone is a big hit with the US Navy since if the stars align, it can stay in the air for over 30 hours. Theoretically, it could withstand transits of up to 550 miles or 900 kilometers, for example, to reach a ship at sea. The drone takes off under the control of an operator who sets its course using built-in GPS, while another operator at the pickup point takes over on arrival. Keep this info on the down low, however, guys, because if Amazon ever finds out about this, your local supermarket is going to be out of business quick. CNIM System Industrial demonstrated the PFM motorized floating bridge and the Rocus unmanned route clearance system at the Eurosatory 2024 military show. The floating bridge is designed to increase mobility of military units. It can be quickly deployed and used for letting not only people but also heavy equipment cross. The Rocus unmanned route clearance system is designed to detect and neutralize threats, making sure military convoys can pass safely. It combines advanced robotic solutions and can also serve as protection for personnel and other assets. However, once cartels start using Rocus, then we know it's legit. Another company with a funny name, this time from Belgium, John Cockerell Defense, presented its flagship product at the exhibition, Cockerell IX. The vehicle is positioned as the world's first ground-based interceptor and a revolutionary combat system for interdiction and territorial defense. According to the company, Cockerell IX never misses. It's lightweight, low profile, but most importantly, the equipment on board can combine data from various sources, such as smart helmets, onboard AI, cameras, and other sensors. It can be parachuted from an airplane, thrown off a ship into the sea, and dumped by a truck. Dear John Cockrell Defense, if you're ever going to try to find another name for the IX, just call it Tom Cruise. There were more exhibits and companies, but this was Eurosatory 2024 in a nutshell. What do you guys think? Are we closer to security with all these military gadgets lurking around, or not? Let us know in the comments. So if you're already subbed to Pro Robots, then Tango Yankee to you. Otherwise, subscribe to the channel, like this and other videos, and check out our Instagram to stay tuned for more from the world of high tech.
The exhibition of naval robots and technologies Euro Naval 2022, robot passenger robot, cyborg pigeons, and the results of Tech Day of the Chinese company XPeng, robot centaur, and mind reading with fMRI. All of this and other high-tech news in today's one episode. Let's get started. Imagine a mobile robot that's been designed to enhance the indoor and outdoor advertising experience, attract greater attention, and engage with customers. RoboAds Company, one of the fastest growing leaders in the digital signage robotics industry, has showcased its latest signage robot during GitX this year. RoboAds robots can be used for advertising, telepresence video calling, wayfinding, gaming, and other possible customizations. It's like a mobile service kiosk that goes to the customer to provide a better experience. They can be placed in any busy public place, like airports, malls, stations, shops, or trade shows, and autonomously roam around the venues. RoboAds robots definitely stands out as one of the most unique and most advanced robots to be recently showcased during GitX. Find RoboAds contacts in the description. Rapid-fire autonomous turret for destroying drone swarms was presented at Euro Naval 2022 Naval Exhibition in Paris. The novelty was presented by Nexter and Thales. In modern warfare, assets worth billions of dollars such as warships face cheap but deadly threats such as drones, floating mines, barraging munitions, and more. The Rapid Fire is designed to deal with these threats and is capable, according to the developers, of finding, capturing, and destroying threats both on land and on sea, all on its own. For fast fights, there's 140 rounds in the rack, which should be enough for about 30 interceptions. The turret can also be controlled remotely. It's equipped with a Thales high-precision optronic fire control system with multispectral sight and high-speed laser rangefinders. Rapid Fire can automatically select appropriate munitions for specific threats. Rapid Fire is scheduled for development next year and for maritime qualification aboard the French Navy replenishment tanker. And for land use, the system can be adapted to the Caesar Mk2 truck chassis and other platforms. Also on display at the show was the latest Blue Shark warship from the French company Naval Group. It's an above-water concept ship consisting of the main body and 2 floats. The design provides half the ship's resistance with maximum rollability and low acoustic signature. The creators promise that the Blue Shark will have a high combat performance, guaranteed readiness to go to sea, high radar stealth, and a fleet of unmanned vehicles on board. The ship is to incorporate some 20 advanced environmental technologies, from propulsion to energy management, including materials onboard waste treatment systems. The idea behind the Blue Shark is to combine the highest combat performance with environmental technologies. MBDA presented at Euro Naval 2022 a solution for countering maritime drones. It relies on a number of sensors and effectors such as the Mistral 3 air defense missiles and the Akero ground-to-ground missiles. The system can effectively neutralize any form of threat, from UAVs to small unmanned surface ships. Being modular, scalable, and evolvable, the system can be tailored to specific customer requirements to effectively and appropriately meet specific complex operational scenarios. Rafael Advanced Defense Systems demonstrated its entire portfolio of integrated naval solutions at the show, including the Rafael Seabreaker. It's a high-precision, long-range autonomous naval strike anti-ship missile that allows for operator intervention at any stage. It uses an electro-optical homing system, computer vision, artificial intelligence, and decision-making technology with an ECM immunity. The Seabreaker delivers spot strikes from distances up to 300 kilometers against stationary and moving sea as well as land targets at high subsonic speeds. More on the topic of military tech. You've probably seen this video, but in case you haven't, the Chinese company Kestrel Defense demonstrated the throwing arm of an armed robotic dog by a drone. According to the defense company, the drone, which they call the Red Wing, can move behind enemy lines and conduct a surprise attack by dropping a robot dog, and it turns out to be fighting dogs descending from heaven. China continues to amaze. Chinese researchers from Shandong University of Science and Technology recently created a cyborg pigeon. They implanted a chip in the bird's brain and then attached a solar panel about half the size of its smartphone screen to power the device on its head. As a result, the scientists were able to control the pigeon's flight for 2 hours. At the same time, the bird performed the command sent to it with up to a 90% probability. Specialists so far think that these experiments will help find the perfect way to control living organisms. But the real image for nightmares was invented at Harvard. Researchers have introduced a robotic grip similar to a reviving tentacle. Let us know in the comments, what do you think of this? The developers decided that a human hand capable of grasping any object was too difficult to replicate in robotics, unlike squid tentacles. The artificial tentacles are made of hollow rubber tubes. On one side, it's slightly thicker than the other, and when it's empty, they become sluggish and seem lifeless. But when they're filled with air, they can shrink and twist more or less randomly, encompassing objects. The individual tentacle is weak, but in a group they can hold objects firmly. Would these replace usual grippers in warehouses? No, but items grabbed at random are very difficult to put in place accuracy. The Chinese company XPeng held its Tech Day, where it talked about its own fleet of robotaxis, a flying car, and a robot with artificial intelligence. The company's G9 SUV was the first production commercial vehicle in China to pass the government autonomous driving test at a closed proving ground. As a result, the auto was allowed to go on road tests without any upgrades, which is very good for production models. The G9 uses the XNGP, an advanced driver assistance platform developed by XPeng that supports driving scenarios from freeways to challenging urban roads. The platform is supported by significant hardware upgrades, including 508 TOPS of processing power, a dual LiDAR system, 8-megapixel HD cameras, and a new software architecture called XNet, which is supported by a self-driving artificial intelligence and feedback data system. XPeng Aero HT also unveiled the latest version of its vertical takeoff and landing flying vehicle, which recently completed its first successful flight, as well as several single-engine failure tests. In driving mode, the car is comparable to any other normal car, but while in flight mode, the steering wheel and gear levers are used to move forward and backwards, make turns, climb, descend, and hover. Toward the end of the event, XPeng unveiled the latest prototype of its robot, which now features a more complex mechanical structure with higher gear efficiency and a more powerful drive, a high-tech computing platform from the robot car, and a battery and temperature management system. The robot's motion control system has also been significantly upgraded to better adapt to difficult indoor and outdoor terrain such as stairs, steep slopes, and gravel roads. Deep Robotics conducted a research test of the autonomous coordinated operation of a group of Huawei X20 robotic dogs. The 5 four-legged robots had to detect all the objects on a soccer field, sharing information with each other to increase the speed and efficiency of the survey. The Italian company Idra sent a giant gigapress casting machine to Elon Musk. The equipment, with a total of 9,000 tons, is already waiting in the assembly shop of the Tesla plants in Texas, where they're preparing to start a serial production of the Cybertruck electric pickup truck. According to the developers, it's the world's largest injection molding machine. Last week, Musk wrote that the Texas-based Gigafactory is in full swing to install the new equipment. The company is set to begin production of the Cybertruck in the middle of next year, and Musk intends to personally run the beta prototype of the pickup in the coming weeks. Researchers from Harbin University of Technology have created the most impact-resistant robot finger. Importantly, it's also functional. The antagonistic variable stiffness finger mechanism is powered by a gear train, and its principle of operation is based on the concept of mechanical passive pliability. This means that the contact forces between the robotic arm and the rigid medium are controlled. The mechanical finger absorbs physical influences that can change its stiffness depending on the task to be performed. The 480-gram 3D printed prototype performed well in a series of tests, proving its reliability and functionality. The drone manufacturer Skydio showed incredible footage demonstrating an intelligent system of evading obstacles. The Skydio 2 Plus drone is designed to shoot cool videos in which you're the only operator, director, and actor. In tracking mode, it can even film in the woods. Subscribe to the Pro Robots channel, like this video, and if you haven't done it already, check us out over on Instagram.